Hello, programming languages students. Today we're going to hit an important topic, one which we will certainly be using in all of our assignments for Prolog, um, which is the topic of lists. So, in Java and in other languages, you have arrays, array lists, collections, and it's no different in Prolog. So here I'm going to show you a simple list. Let's do Vincent and Mia again. And we'll set Vincent and Mia as a list here. Now, I'm not going to run this command because this doesn't do anything quite yet. Um, but what I want to show you is that we use square brackets for lists in Prolog, similar to using square brackets for arrays in Java. And if I set it equal to a variable, you'll see that this stores, and this is fine. This works. Now, lists in particular are not that exciting on their own. Um, the there's a couple interesting points, I suppose. You can have within Prolog lists, you can store variables, you can store numbers, you can store predicates, you can store other lists. All of these things are fine, and if you run this, you'll see that all of this happens, and all of this that gets stored. We have a variable in the first spot, a number in the second, a predicate in the third, and another list in the fourth. So this list has 4 elements. Um, and it runs and it works fine. And so basically you can store whatever you'd like to in a Prolog list. There's no data type restrictions, nothing like that. And so that's great. We can store things, we can create lists. How are we going to work with lists? What do we do with them? How do we find interesting information? So, in Java or Python or most of our normal languages, if we wanted to do something with a list or an array, it usually involves looping through it, looking at the first element, then the second, then the third, then the fourth, and trying to find some pattern of some sort, right? And so in Prolog, we're also going to be able to quote unquote loop through the list by breaking it apart into pieces and then basically recursively iterating through the list by breaking it apart into pieces. So we'll do some examples of a recursive method in a little bit here. But what I wanted to talk about first is how we start. Um, so there's an important operator here in Prolog, and that operator is the vertical bar. In Prolog, the vertical bar means I want to split a list into its head and its tail, where the head is the first element in the list and the tail is the rest of that list returned as a list. So if I run this, the head of this list is X, and the tail of this list is everything else as a list. So we have a head and a tail. And so if you think of this, it's hard to envision right now, but as we kind of go through, what you'll want to do is go back and think about this as setting up a loop where we're going to take the head of a list and do something with it, compare it to something, make sure it's the same as something by setting variables the same, and then pass the tail in to a recursive version of the list or a recursive version of the predicate or the function we're writing, so that we will basically run the same function, run whatever comparison we're running, but on the tail of the list. And so then that will break the head of the list off and then get the tail, and we can move on from there. Um, and so you can basically, through this process of breaking every list into a head and a tail, and recursively passing the tail back into a predicate, you can essentially go one element at a time and iterate through a list. Now I'm jumping ahead of myself a little bit here. Let's do a couple more examples and make sure that we're comfortable with basic list syntax. Um, so a couple things about lists that will be helpful in the future. Let's jump back down to a 2-element list and split it up. Let's do Marcellus and Mia. All right, so the head is Marcellus, the tail is Mia. Now I've mentioned that the tail of the list is always considered a list, and that is true. And so you'll notice here the head is just an element, it's just an atom, Marcellus. The tail is a list. So This is going to be an important piece here because a predicate can only split something into a head and a tail if there's at least one element in the list. So when you get to the last element of a list, let's say the head of this list is Mia, then the tail is this special thing called an empty list. So it still returns a list, but a list with nothing in it is called empty. And if you try to run a predicate or run a something that splits a list into a head and a tail, and the list is empty, it will return false. So this is often our stop condition. If we are unable to split a list into a head and a tail, our predicates are recursively looping through lists will stop. So this allows us to go through every element of a list and do some sort of comparison or check with it, passing the tail back into a recursive call until the tail is empty, and then our recursive calls will stop because they're false, and we'll move back up through our list. Um, so that's kind of the key usage here. We're going to do several examples about how we can actually write predicates and write functions using lists and splitting them in this way. But one last thing I wanted to talk about before we basically end this little really short introductory video on lists. The last thing I want to talk about is how we can actually do a little bit more if we want to with lists. So let's say we had Marcellus, Vincent, and Mia as part of our list. Um, One thing we can do, let's use x and y variables here. And actually, let's do this. This is another thing we can do with lists. So again, this vertical bar is where we split. So if we do x comma y, vertical bar z, what do we think all the values are going to be? Well, if this should be the head of the list, and the comma, what the comma will mean is that we actually separate and get the two elements at the head of the list. So if you need to go through a list and compare one element to another, as you loop through, this could be really helpful. And so we would get x is going to be Marcellus, y is going to be Vincent, and z is going to be Mia as a list. So, you know, this is similar to in Java if you have a loop where you're trying to compare um, an array at element 0 with an array, or array at element I plus compared to an array at element I plus 1. You can do similar things in Prolog by splitting lists this way. And so let's see, let's add Jody and Yolanda here. Let's make a 5-element list. And then let's see, let's say we wanted to actually compare several elements of the list. So let's say we wanted to compare 4. Um, well, we can get x1, x2, x3, and x4 as Marcellus, Vincent, Mia, and Jody. And then Yolanda here is left over at the end of the list. So we can do it with 2, we can do it with 4. However you'd like to work with this, you can. And then one other little piece here is let's take a look at anonymous variables. So we talked briefly about this in another video, where underscores are anonymous variables. So let's say whatever list you're given in, what you care about is that it has at least 4 elements, because we have 4 variables here. Um, but of the 4 elements, you only care about the very first element in the list and the third element in the list, for whatever reason. And you don't care about the second, you don't care about the fourth, and you don't care about whatever is left over. So you want to compare the first and the third elements of the list and get rid of the rest. Well, this is a really good way of doing it. This is what anonymous variables, a really good use of anonymous variables, where you can grab Marcellus as x1, Vincent gets thrown away into an anonymous variable, Mia comes out as x3, Jody gets thrown away as an anonymous variable, and then we also don't get our tail of our list because this is also an anonymous variable. So there's a lot of ways to manipulate and work with lists and look at only specific elements of a list and write functions to only look at specific elements of a list. But this is kind of basic list syntax, and you'll notice that in every one of my examples we have this vertical bar because this truly is the key component here. In Prolog is that when we break a list into a head and a tail, that allows us to do manipulations. You know, it's almost like in Java, if you're ever working with a list and you don't write a for loop, you have a problem. If you're ever working with a list in Prolog and you don't have a vertical bar, you're probably not doing anything significant with the list. So this is an important piece in understanding how it breaks apart the head and the tail of the list. Understanding that once you try to split an empty list, your recursive methods or predicates that you create will stop because you'll get false. These are all key concepts. And so we're going to give a few examples about how this works and a couple of basic um, recursive structures, recursive predicates that are really, really helpful in patterns that you'll see over and over and over again as we go through. So please let me know if you have any questions. Thanks.